And we're going to go into Inception here. And we're going to go into Inception here. Good, that looks all right. Good, that looks. Okay, can someone confirm in game that I am coming through okay on the screen?
I think you're slightly quiet. It is double broadcasting, that's correct, but that's good because that means that both the in-game virtual thing and the in-game actual slide are working, so that's good.
All right, I've turned off my in-game broadcasting so that it's just YouTube broadcasting now. Okay, you can adjust your volume with the button at the top if you'd like. And it looks like we're broadcasting okay, so now I'm going to try and get my slides up and running. So I'm going to do that by trying to present my slides in a window. And I have gone and done that, I think. Oh, there it is. Okay, sorry, missing window. All right. And I have got the window showing. I'm not broadcasting it yet. Let me attempt to do that. And there we go. Broadcasting slides. All right, great. Let's roll. All right, so we're going to talk a little bit about the context of big data, and we're going to do that to try and get a little bit of a place from which to start working on the technological infrastructure. Web search has been around for a while, and one of the things that you're going to see as we read through chapter 19 is some of the historical context for where it's come from. That's important because a lot of the reasons why we do things the way we do are because of a historical trajectory, things that have happened along the way that have caused us to make decisions about the way that the web works and the way web search engine works, including just the way that the web itself is structured has caused us to create search engines in a particular way. So this lecture is called Wherefore Art Thou Big Data, or What is Big Data? Why is big data? What is it that makes something big data? And we want to talk about that a little bit. If you have questions, a great way to ask questions is to put it in the chat window. And if I don't see you, if you want to stand up and go stand on the wooden platform, I can move so that I'm looking at you all. I think chat's probably the best thing. Screen is a little zoomed in, at least for me. What do you mean by that? What is the top and the bottom cut off? Is that what you're saying? Which edges are cut off? Are all of them cut off? Okay, looks like maybe there's some UI stuff that Ben's helping you work out. For the time being, I'm just going to shrink the size of my slide window. Maybe that'll help us. All right. So big data. What I'd like to do is talk a little bit about big data, talk about some of the things that we consider when we do big data. And oh, looks like you got it figured out. Okay, so we're back to big size. Big data, big slides. So I want to talk about what big data is, how is big data used, some of the good, the bad, and the ugly of big data, a couple ways to think about big data, some particular academic models of it, and will be familiar to some of you. And then thinking a little bit about how we ought to live in the face of big data. Going forward, let's see, and we have 3 more lectures after today, and the next 3 lectures we're going to be covering more directly the content of chapters 19. So I encourage you to get chapter 19 out and read it, Web Search Basics. And then after we do that, there's going to be a quiz, a take it one time but open book quiz that I believe is going to go live on the 16th, if I remember how I indicated it correctly. And that'll cover both chapter 19 and the content of the lectures, because some of it is a little bit, so there's extra information in the lectures as well. All the slides from the lectures will be available, the output of the PowerPoint will be available to you on Canvas. But I recommend doing some active note taking as well, because that helps you to synthesize the data that you're learning while you're hearing the lectures. Even if you never go back and look at the notes again, it turns out that just the process of writing down notes helps to organize things in your head and learn it. All right, so big data. Big data is kind of a vague term. It's a bit of a business term, and it talks a little bit more about strategies and aspirations necessarily than it's a specific technological definition. So broadly, it's a term for data sets that get too big or too complex that traditional data processing applications are inadequate. And so in particular, there's a course going on right now that John Rodkey's teaching on databases, and databases are not big data. Databases are, there may be a lot of data, but what's different about a database is that for the most part, it is able to be examined on one computer, even if it's a super beefy computer. Big data is so big that we have to use new techniques because they can't fit on a single computer. And I'm going to hopefully demonstrate that to you with our next programming assignment, in which I'm going to ask you to sort some data. And unlike the first assignment, the cute data, the Quaine data assignment, this one's going to require you to think a little bit differently, because you're not going to be able to keep all the data in memory at one time. And that's going to challenge your ability to just use the generic sort methods that come with Java data structures. There's so much data in the case of big data that it becomes very hard to capture it, like to just collect it. It's very hard. It's very hard to store it, because how do you store data that doesn't fit on one computer well? It's hard to curate it. How do you make sure that the data that you're collecting is valuable? That's what I mean by curate. How do you get rid of noise and errors in the data? How do you do that when you're getting it so fast and furious that you can't really do it as a human process? How do you analyze it? How do you search it? A big point of this class. How do you share it? How do you transfer it? Because just transferring data is remarkably hard. In fact, Amazon has this ability that if you store a lot of data in Amazon's online cloud database, a database that they host for you, and you would like to export it, they have a service where they will actually FedEx you a hard drive that has your data on it. Because as they FedEx your hard drive, and actually it's in this super secure box that you can only get into with a separate key, with a digital key. So it's super secure. But the reason why is because it's so much faster to put your data on a hard drive and to FedEx it to you than it is to actually get it across the internet. The bandwidth of shipping a hard drive is much, much larger than trying to get it through normal internet channels when you're dealing with this much data. The latency is bad, but the bandwidth overall is much faster. Sometimes in computer science, we call that sneaker net, because it's equivalent to getting a flash drive and walking it across campus to someone else, and then plugging it into their computer, wearing out your sneakers in the process. That's why it's called sneaker net. And that ends up being faster a lot of times than trying to transfer the data automatically, which is sort of funny. At my home, the internet is so bad. How bad is it? It's so bad that today there was a big email thread among all the faculty about whether or not internet was working at home, and it wasn't. And so when I need to upload something substantial, I'll actually get in my car and drive over to the baseball field, because the Wi-Fi at the baseball field is so much faster than my cable internet at home. Do not fear for me, though, because I have signed up for Starlink. And as soon as that's available, the best phone call of my life is going to be calling Cox and telling them I quit. I can't wait. Big data suffers from these problems of transfer, visualization, and then also dealing with all the privacy that's associated with it as well. But when it's used in a business context, it means kind of a business process. And it means that you intend to do things with your data that's smarter, and that's faster, and that's more insightful. When you say your data leverages when your company leverages big data, what you're really doing is you're saying you're going to do a lot of data analysis. Like your company is a strategic differentiator, a kind of competitive advantage that you have is your ability to do data analysis of a lot of data that you're collecting in your company. So, when you hear someone say big data, it depends on what company you're keeping as to what people are talking about. All right, technically we don't have a specific example, but let's talk a little bit about some of the barriers for this. So the first time when you realize that you're working with big data is when Microsoft Excel crashes, and we've mentioned this before. You get past about 65,000 rows of data, and Excel no longer wants to play well. All right, so a lot of people use Excel as a quick and easy database, but it quickly runs into trouble. The next thing happens is when you run out of data on your computer, when you run out of memory on your computer, and this means both RAM. Primarily, it means RAM because when you do something like sort an array list, that's going to be very, very fast as long as you have enough RAM to hold the data that is in your array list. So, for example, in the programming assignment that you're working on, the Quaine data, some of you are using the example that was in the Canvas assignment, the example that had about 6 letters, 1 line for each line of the input. And not surprisingly, it's easy to load up 6 lines of text into the available RAM that you have. Most of you will have something like 8 gigabytes of RAM, maybe as much as 64, depending on how crazy your laptop is. And with that much memory, you can hold a lot, 64 gigabytes. Did I say gigabytes? I meant to say gigabytes. You can hold a lot of memory, a lot of data in that memory, and as long as it fits in memory, you can move it around pretty quickly, and so that's good. So first breakpoint is Excel crashes. Second one is you max out your RAM. The next thing is that you can't fit it in your disk drive anymore, and this is the low disk space warning that you get. Some of the different kinds of data structures that you use are pretty seamless about transferring data to the disk for the data structures. So for example, there are kinds of data structures, and we will end up using one before the class is done, one called Berkeley Database. And what is nice about this data structure is that it works like an array list, where you just put stuff into the array list like you would in a loop or in your code. And if you run out of RAM, the data structure itself is smart enough to store stuff on the hard drive when you run out of RAM. And so it looks like you have much more data space available to you than your RAM would allow because the data structure is managing storing extra data to the disk for you and then retrieving it from disk when it needs it, effectively treating your RAM, your 8 to 64 gigabytes of RAM, your primary storage memory, treating it like a cache for a database that's stored on your hard drive. All right, nevertheless, you can get to the point where you can't fit your data on the disk of that machine either. Another breakpoint, moving you more towards a very clearly big data environment. Another way you know that you're in big data is because it would take several days or months or maybe years in order to process the data the way that you want it to. For example, trying to sort it. If you want to sort a lot of data, it can take a long time because we know that a bad sort algorithm is order n squared. Even a good sort algorithm, that's order n log n, still grows faster than the size of the data. So as we go from 10 data points to a million data points, the time doesn't go from 10 data time units to a million data units. It goes from 10 time units to a million log 1 million time units. It's growing faster than the data. So it's taking longer and longer and longer than even just a linear increase in order to process the data. It's bad for big data. You might also be using terms like terabytes or petabytes or exabytes in order to describe your data. There is a little bit of a discrepancy that these terms, the exact number that are associated with them is shifting right now because of some lawsuits actually. So there are a pair of words now that we use in conjunction with one another. We use words like kilobyte, and now we use another word called kibibyte, and we use megabyte, and we use mebibyte with a B instead of a G. And the words that you're used to, like kilobyte, megabyte, gigabyte, terabyte, these have now been interpreted as being powers of 10. So basically powers of 1,000 as you increase in the size of each of them. As you know, computers don't use powers of 10, they use powers of 2. And the lawsuit was about disk drive manufacturers advertising one size of a hard drive, but people not understanding that that was a power of 2 or a power of 10, and they sued the hard drive manufacturers for being deceptive about how much was being stored on the hard drive. And as a result, there's now a move driven largely by industry to clarify whether you're talking about powers of 10 or powers of 2. And the words that we've always used now mean powers of 10, which is unfortunate because it means that traditional computer science understandings of these words have been shuttled aside for uh, consumer reasons. So anyway, the numbers that I'm about to show you are the powers of 2 numbers. So a terabyte is 10995116277776 bytes. Petabyte, throw another couple powers on there, another couple powers of 10 on there. One, what is that? See, there's thousands, millions, billions, trillions, 1 quadrillion bytes and change. And then we have 1 exabyte, which is 0, what's that? Thousands, millions, billions, trillions, quadrillions, 1 quintillion and change. Again, these are powers of 2. These are really large numbers, but they're not numbers that are so large that you don't actually encounter them in working with big data. And we'll see a couple examples of why and when that is. So this graphic is a little bit old, but it still is relevant for trying to describe how much and where this data is coming from. And you can look and you can see some of the things that happen in 1 internet minute, and this was in 2016, so 5 years ago. The time difference isn't quite as big a deal, I don't think, as the pandemic difference is. So the fact that we've gone through a pandemic and everything moved online, I think has probably driven an increase in this number more than just the passage of time. As more and more of our activities have been forced to be online, the amount of data that we're collecting online has grown as well. Nevertheless, it's interesting to look at a few of these. Let me pull a few of them out. Every minute at Amazon, there's $203,000 in sales. That actually seems kind of low to me right now. It seems like that's probably gotten much higher since the pandemic and over time. You can see that there's 2.4 million search queries per minute. Also, probably has gone up. YouTube, 2.78 million video views per minute, an enormous number of views. Now, the point to recognize about this is these are all consumer applications, things that you are more or less aware of because they're sort of consumer-facing applications. But every one of these things that you do, sorry about that. Every one of these things that you are doing on the internet comes with an enormous amount of data tracking that's going with it. So you know when you watch a view, it's not when you watch a video on YouTube, you're clocking that one person has viewed that video, but on top of that, it's being clocked that you watched that video and statistics about your demographics and what time of day it is and whether or not you. Okay, I'm sorry. I'm going to try and turn off. I'm going to try and. What do I do? I'm not sure what to do beyond do not disturb. Let me try and do not disturb on my watch, see if that changes anything.
Alert from Kalimba. Pick up Martha from school.
All right, I got to figure out how to get.
Pick up Martha from school.
I've got to figure out how to get my computer to actually not make noise when I would like it to not make noise in terms of disturbing me. So if any of you have any clues on how to do that, I would appreciate it. It used to be before the update in the most recent operating system that just putting do not disturb on did that, and it's not happening anymore. So anyway, when you interact with these websites, a lot of data is being connected. Oh, that's actually, I don't think it's the fact that I have Calendar app running that's what's causing it. I think it would give me those warnings anyways, like reminders. I don't know. I'm just gonna be at peace with it, right? I receive those unexpected notifications and I accept them as a part of life online. All right, so all kinds of different sorts of data are being collected here about you, but also about the view. Like this isn't a story about. Oh my gosh. Okay, I'll try quitting it. It's not running. Let's see. I'm worried about what happens if I mute my computer in an online broadcast situation, but let's give it a shot. All right, I'm going to talk. Well, if I mute, what am I going to lose? I'm going to lose. I'm going to lose the audio that I'm listening to that's helping me to understand what's happening here. Okay, I'll put a note down to see if I can figure out how to mute that later. All right, my apologies. All right, moving on smartly. A lot of data collected. A self-driving car, for example. This is a visualization of a self-driving car going through the environment, and what you see is you see a lot of visualizations of the data that's being collected. So for example, the green dots are a reconstruction of the 3D environment, and what you're looking at is you're looking at reflections from a LiDAR. A LiDAR is a laser radar. It circles around, so it looks like a little R2-D2 that sits on the car. There's a mirror that spins around. A laser hits the mirror and bounces out into the environment, and a detector detects whether or not the laser reflects back. So as a result, you can get a lot of feedback about solid objects in the world. However, it creates shadows. So obviously you can't see things behind the solid object that the laser hits. And that is why the green dots have the presentation that they do, where they kind of shadow everything behind it. So if you look at, for example, what looks like the street sign or the stoplight down in the bottom, you can see that there's kind of a shadow of dots that's created behind it, because anything behind that street sign, the laser is being blocked by the street sign. Nevertheless, you can get a pretty good representation of solid things in the environment from the LiDAR. On top of that, in this particular environment, an analysis is being done and blocks are being drawn, wireframe blocks are being drawn around some of the things that have been identified, and that means that the software has detected certain kinds of objects in the environment. So you can see the pink objects, the pink boxes are surrounding the green dots that have been interpreted as moving cars. And the black boxes surround things that look like they're parked cars. And you can see there's a blue box which is surrounding a pedestrian. In addition to that, we have a few more LiDAR. The orange is LiDAR as well, but that's focused on hitting the ground rather than objects in the environment. So anyway, the point of this, though, is that as the car is driving around, it's collecting 45 gigabytes of data per minute. And this is a great example of big data. You have to have basically a small data center on your car if you're going to store all this stuff. And then you're talking about how do you get it off into the cloud to do bigger analysis or to do reconstruction of city maps or anything like that. It's quite a bit of time to transfer 45 gigabytes. If any of you have ever tried to upload a movie onto Canvas, you know that. Here's some other data points for where big data comes from. So for example, the movie Avatar, the one with the blue CGI creatures, that movie is sort of famous for being a super intense CGI movie. I actually saw it for the first time over the summer. I just seen clips from it, and I was a little bit surprised by it. I kind of liked it, and I thought the graphics were pretty amazing. I don't know why I wasn't expecting that, but I was, or I wasn't, and I did. And it created one petabyte of data in order to keep track of everything that they kept track of, models and graphics and digital environments and renders and all that. Like I said, Google self-driving cars are 45 gigabytes per minute. We've got about 43,000 gigabytes of internet traffic per second, but of course this is only certainly grown a ton. 75,000 tweets sent per second. I can only imagine that's higher now too. 776 Instagram photos per second. How could that not be larger now? Tumblr posts, Skype calls, Google searches, YouTube videos, and emails sent per second. All those complicated stats, like there's a lot of questions about what those stats mean exactly and what counts. But nevertheless, just to give you sort of a sense of where all this data is coming from. And again, this is just the consumer side. So let's talk a little bit about things that may not be quite so obvious, but an example of that would be Walmart's data warehouse. Walmart had one of the first data warehouses. You're probably more familiar with Walmart having physical warehouses, much like Amazon has physical warehouses. But Walmart has also pioneered the data warehouse concept, and they capture every transaction at each one of their stores, and they translate that into real-time inventory information. And more interestingly, they translate it into real-time shelf information. And so really interesting things happen if you're a provider of something that Walmart sells. They'll track on kind of a real-time basis how well your products are selling in different environments. and they will rent out different shelf space to you as a manufacturer with different costs. So you have to pay for where you want to be placed in Walmart. A top shelf is a premium shelf, one that's on the eye level of an adult is a premium shelf because it's easy to catch someone's eye, unless you're some kind of product that is geared towards a kid, and then you want to be on a lower shelf. So like you think Apple Jacks or some kind of cereal, making more sense on a bottom shelf, notwithstanding the primary diet of college students. In addition to that, if your products aren't selling very well, Walmart threatens to remove you from the shelves. And one way that you can up the amount of product that you are selling is to buy an end cap from Walmart. An end cap is the location on the end of the aisle that usually has special promotions or special displays. Probably recognize it from the drugstore. You'll have things on the end cap that a lot of times I associate it with like for some reason makeup I associate at the drugstore being on the end cap. If you go in Trader Joe's doesn't operate like this, but they make good use of their end caps. They'll put like the hot dog Memorial Day barbecue end cap, where they'll put like chips and hot and ketchup and mustard, or they'll do like a Cinco de Mayo end cap and they'll put like limes and tequila and margarita mix and put all those things in an end cap. Walmart treats that as a premium location and requires people who are selling products through their store to pay for those end caps or they get removed from the shelves. It's a really, really interesting business model because Walmart, in some ways, is treating their stores as places that product providers rent out, like a salon rents out the chairs to a hairstylist. Walmart is treating their stores a little bit like that. And that's an interesting, different way of thinking about the world that you probably don't think of as a consumer. The point for big data is that all of those the ability to rent out that space and to offer different deals and to move stuff around in the store to the manufacturers is driven by their big data warehouse, generating, I don't know, a million transactions per hour. Who knows exactly how accurate that is, but roughly. And they have about 30 petabytes of data in the data warehouse. Very, very difficult to make sense of it. It's like very tempting to want to be able to look at that data warehouse and try and deduce what is sold and what gets sold with what and all kinds of different sorts of machine learning things you'd love to do with it. But the data curation, getting the data, processing the data, there's so much of it. It's very, very hard to do that kind of analysis well. But they've been working on it for quite a while. I know that I had a friend that was working at their data warehouse in about 1998. And so he moved from Arkansas and moved to Seattle and left their data warehouse to go do um, work and other stuff in the Seattle space. All right, so that's a good break point for us to look about the next topic, which is how is big data used. But let's have a moment to just have a question or comments about that. Anyone does that raise any thoughts for anyone? Let me drop out of YouTube for a second. We can chat voice-wise in game. All right, I'm going to briefly.
Listen, I can't hear him. No, that wasn't intentional.
All right, so what do we do with that data? A lot of different things. Like we said with Amazon, what happens in it with the Amazon big data? Well, while users are browsing and buy, oops, sorry, double broadcast. I actually hit the button. Thanks. All right, so while users are browsing and buying and reviewing products, Amazon is keeping track of all that. So here's a particular product, the Weber kettle grill. And as you walk through it, data is being collected. So all kinds of data. So for example, you as a customer can review that product and they're going to aggregate that data into the reviews, 1, 2, 3, 4, 5 stars, what percentage of people rated them at different stars. We've got to keep track of that in a database somewhere, right? There's somewhere where we're keeping track of these customer reviews and we're analyzing it and it's all associated with that grill. And we can actually see the review and the star rating, but we also know what time the review was entered. We know who entered the review. We are also giving an indication of this verified purchase, which means that that person actually spent money in order to get this product as well. So all these things are like being kept track of in order to give you a better customer experience. Customers can upload their images of them using this grill. They can upload videos, actually, how-to videos, all kinds of data around it that's being used to enhance the understanding of the product along the way. Now we can also look at sequences of images, sequences of products. And so customers who viewed this item also viewed, well, what does that mean is happening on the data collection side? It means that as you are browsing products, you're creating a trail of products that you are looking at. So you're looking at product A and then product B and then product C and then product D. Maybe that's all within one session on a web browser, meaning you've opened the browser and you've looked at A through D and then you close the browser or you make a purchase, something like that. That trail of products that you look at is very valuable because it suggests that you're comparing things in some sort of intelligent way. And that data can be mined and treated as a product. Much like our behavioral surplus in our web search environment, this Amazon browsing experience creates behavioral surplus that can create new kinds of products that Amazon can offer to you or use to enhance its existing service. And one of the things is customers who view this item also viewed. That requires a lot of data collection. Every single person that's on Amazon, not when they make a purchase, but just as they're browsing items, the fact that you're browsing things in sequence is important for being able to capture that behavioral surplus and make an interesting product out of it. Not just people who viewed things, but you also have a trail of things you bought. Now, this is probably outside of a session, but if you buy a grill, you're probably also buying a charcoal lighter, which is that second product there that looks like a can with a handle on it. Maybe you're buying a grill cover as well. And the reason why these things are being suggested to you is because other people who have purchased the thing that you looked at before that you're currently looking at, we've recorded what else they've purchased. And now we're going to aggregate that and we're going to say, oh, well, for people that look at this grill, we know that 10% of the people who look at this grill go on to purchase these other things. And that's really valuable for Amazon as a product. It's behavioral surplus. It requires analysis of big data in order to do this. Across millions and millions and millions of customers and purchases, they're able to create these kind of predictive products on our behavioral surplus that are really, I mean, quite frankly, are great. Like, I think it's really helpful to be able to look and see what kind of accessories may be out there that maybe aren't being sold by the same manufacturer, but that other people have found helpful. Like, I think this is great. I think this is a great product. And then also you get this kind of thing. This is called a market basket analysis. And so this is looking at how people purchase things together. So not just that someone who purchased diapers also purchased beer, a common consumer habit, actually, sort of stuff of marketing lore. But you can also see that, oh, when people buy the grill, they go ahead and buy the charcoal starter and the grill cover at the same time. So there's a market basket analysis. They're looking at what's in your shopping cart, your virtual shopping cart in this case, and turning that into a product in a digital environment and letting you buy all of those things at once because other people found those three things helpful as well. Of course, this creates a feedback loop because once you purchase these three things together and then offer them to someone else, now you're reinforcing the idea that people buy these three things together. And that data is tainted a little bit by the fact that you're offering this as a way to buy things together. So it's something to be careful of when you do the analysis. Now, in the physical domain, more of the Walmart domain, they also do this kind of market basket analysis. But what they do with the market basket analysis is rather than like offering for you to buy these things together, they'll do things like what Trader Joe's does, which is where they'll take an end cap. They'll notice that people who are buying limes are also buying margarita mix. They'll put all those things together at the end cap so that if you had limes on your list, you might be inclined to buy an extra thing, or to maybe you didn't think about buying those three things together, but it makes sense because of the time of the day or the holiday or something that's going on. Or maybe it's just a recipe idea that you like. The other thing that physical stores do is they'll take these market basket analyses and they'll place the products close to one another. And so you might wonder, well, why are the cake mixes in a grocery store next to the sugar in the grocery store? Like, why are grocery stores so consistent? Trader Joe's is a little bit different, but sort of the Vons, Albertsons, Ralph's kind of grocery stores. Why are they so consistently the same in terms of what all the different aisles have? Like, why are the chocolate chips always next to the Jell-O? That's sort of a strange thing. I do the shopping for my family, so I'm a little bit more familiar with this. But there's just products that are next to each other all the time. And they don't seem obviously like they should be next to each other, but they are. And then there are some products that are all over the place. So for example, if you look for dried apricots, you're going to find them in several different places in the grocery store. You're going to find them in the produce aisle. You're going to find them in the baking aisle. You're probably going to find them in like the natural foods aisle, and you're going to find them in like the trail mix area. Four different places where the apricots are sold. And what's also funny about that is they have different prices depending on where you're buying them. So the same product in the store can have different prices depending on where you're purchasing it from, because I don't know why this is, but typically when you buy it in the context of baking, you pay a lot more than if you purchase it in the context of produce or like an energy bar, trail mix kind of thing. And not surprisingly, if you purchase it in the context of like a natural food or organic section of the grocery store, you pay more as well. Although I don't know what the relative cost is between baking and natural foods. Interesting idea. Looking at a market basket analysis, using big data in a physical store, looking to see what's familiar among different shopping carts, and then using that data in order to change the layout of your store so that you can make more sales, but also do things that are more convenient for your customers, right? It's kind of a win-win because it is a good idea a lot of times, and it's helpful for the store as well. Thoughts? Grocery store experience? back into YouTube. All right, so let's put a little bit of, let's do a little bit of critical thinking about this and think about how we feel about what's going on and maybe trying to think a little bit about the moral valence of what's happening. And I put this down as the good, the bad, and the ugly. This, appreciate any feedback or pushback that you all have, because I'm not sure that these things are all necessarily the way that I categorize them, but it's sort of my gut reaction to what's happening. I'm sort of a gut reaction that's anti-surveillance, though. All right, so I would say some examples of good big data. Search engines, good. Inventory control, good. It is nice to know that when you go into a store like Trader Joe's, that products are going to be on the shelves. And the way they make sure that products are on the shelves is that they keep track of what's being sold. And if they've sold all the inventory that's in the store, they automatically send out an order to deliver more of it to the store later on. So that's good. Automatic translation, I think that's good. So that would be an example of typing in text into Google Translate and having it translate it into a different language or foreign language into your language. That relies on having a bunch of data collected about different parallel texts, one text written in one language and another text written in another language, having all that stored in great quantity and then being able to use machine learning to match up those two texts. Transformations in genetic and pharmaceutical research. I'm going to say that's good. For example, the way in which we use big data to do vaccine research, the way we use big data to create new drugs and pharmaceuticals, the way we use big data to do analysis of population health data. Just being able to analyze genomes, generally speaking, requires big data because of the quantity of data that's collected. Generally, good. Traffic rerouting. I think that's good. If you get on a Google map, you put in your directions and it says, hey, you might want to take a left at the next exit because there's an accident coming up. Requires a lot of data collection. I think that feels good. Targeted advertising. It's better than lousy advertising, I suppose, but it comes with a cost. But I think all things considered, I would rather have ads that I care about and am interested in than having the same amount of data collection and bad, unhelpful ads. Things like remind me to get milk on the way home. That requires a lot of data collection, a lot of analysis. I think that's pretty helpful. It's kind of Siri reminders. Sex offender bracelets. These are GPS tracking devices that are worn by people who have been convicted of sex offenses. And it is a requirement for them to be out in the community. And what it does is track their location. It creates regions in the world that people that are guilty of sex offenses are not allowed to go into. For example, school areas. That's the main one I know about. And that enables people to be in the community rather than locked up, but not complete freedom. So it's not like that's a total win for everybody, and it can put quite a burden on someone who has a bracelet. For example, it becomes difficult sometimes to take a bus because if the bus goes by a school, you can get tagged by your parole officer, and that's not good. So the implementation matters, but generally, I think that seems like a pretty good balance of different kinds of principles in the world. Software project management. If you've looked at GitHub recently, you know there's all kinds of statistics about code commits, code editing, code quality, that kind of stuff. That seems good. Tracking food or hazardous waste, that all seems good. So for example, there were some pretty high profile examples of food being contaminated with like Jack in the Box and Chipotle. And one of the ways that companies that find themselves in a mess of public relations because people keep getting sick from their food being contaminated is that they implement a much more sophisticated and detailed food tracking data network so that they can track food from the farm or wherever they're getting the food from through the processing plants, in the trucks, to the restaurants. And one of the most important things to track in those situations is the ambient temperature. And so they can make sure that at all times their food is in a refrigerated environment because at every step along the chain of logistics, they have a temperature sensor and they can monitor that in real time. That takes a significant effort in instrumentation and deployment. But when you're faced with a crisis of consumer confidence because no one wants to eat at your restaurant because there's been so many highly publicized examples of E. coli outbreaks, it suddenly becomes a very compelling use of big data. And there's, hazardous waste is sort of a similar thing in the reverse. Anyone think that those aren't good or want to take issue with my characterization of them or want to nuance it? I am always right. Good. I'm glad everyone agrees that I am always right. Okay. I'm always right. Carrying on. Carry on. Professor Patterson's right. Ah, shoot. He's right again. There's nothing to say. Ah, what can be done? Nothing. He's always right. Let me show you some logos. I should have been doing that along the way. Sorry. That's an example of the bracelet if you're interested. Okay, this is sort of interesting. Some of you know this story. This is an example of Target using big data. This is a little bit, I would say maybe earlier in the days of data mining. And so some of the nuances of how to do it well hadn't quite been figured out. But what I'm going to do is I'm going to read you a little selection from Washington Post, from a Forbes article about what happened here at Target. So basically what happened is Target started keeping track of doing market basket analysis, much like Walmart had pioneered. And they had a new person come in that was in charge of doing the market research. And they were running tests after tests, I'm quoting now, analyzing the data. And before long, some useful patterns emerged. Lotions, for example. Lots of people buy lotions, but one of Poll's colleagues, Poll is the researcher, noticed that women on the baby registry were buying larger quantities of unscented lotion around the beginning of their second trimester. Another analyst noted that sometime in the first 20 weeks, pregnant women loaded up on supplements like calcium, magnesium, and zinc. And many shoppers purchase soap and cotton balls, but when someone suddenly starts buying lots of scent-free soap and extra big bags of cotton balls, in addition to hand sanitizers and washcloths, it signals that they could be getting close to their delivery date. And so the story that emerged from this is that Target sent out a mailer to a teen woman at her house, and her dad brought in the mail one day and noticed that Target was advertising to his daughter as if she was pregnant. Dad, very upset with Target for presuming that his daughter would be pregnant, goes into Target and creates a big fight with the manager of the Target, who clearly didn't have anything to do with the advertisement, but nevertheless was a convenient foil, yelling at them, threatening them, because they were impugning the virtue of his daughter. Lo and behold, Target was right. His daughter was pregnant and had not told her father yet, and Target figured it out through data mining, the market basket analysis, used that data in order to create an advertising campaign sent to the teen mom's house, unbeknownst to the dad. Dad does go back and apologize to the manager. I don't know what happened with the family dynamics, but you can see how quickly something that looks kind of benign, like a market basket analysis, can suddenly stumble into difficult territory with respect to privacy concerns. Because suddenly something happens in this example where what was sort of just a vanilla market basket analysis starts to stumble into cultural mores and cultural norms in a way that triggers our privacy sensor or whatever our privacy organ is, the thing that bothers us about privacy. Do you think that's a violation of privacy? Like, what do you think about that story? Why don't we have everyone make a comment in chat about what you think about that? Like, just a little bit of feedback. All right, so Landon finds it a little creepy, but not surprising. Talia's surprised that the dad was so triggered by the marketing. Kind of an interesting thought. Talia would have just ignored it if she had been dad. Ethan makes the observation that by sending it to her house, it wasn't just sending it to her; it was actually sending it to everyone at the house, and maybe that was that was the point at which the bad decision was made. Had it been just her email or something private, it wouldn't have been nearly as problematic. Josiah says, so we can make predictions from past behavior. That's not scary, but the same feature can be used in new ways, of course. Right. I mean, a big part of why this is creepy is because it's a new capability, and it's a new capability that's crossing tripwires of really socially sensitive kinds of locations. Noah says, edging closer and closer to cyberpunk. Josh F says it brings more utility to users than maybe they should be okay with. That's pretty dicey though. Probably meaning that like more powerful than people were ready for. Ben A says curious as to whether their cases are similar to that or even something that they buy themselves. For example, that was gathered by search patterns about them that they didn't know. Yeah, well, I mean, I think the thing is that this kind of data mining is happening all the time. Like it's like I mean, like when I open up my Instagram feed, every single ad that I get is for trying to is targeted towards fat fathers. And like I'm not kidding. I get so many ads for t-shirts that are cut to make your dad bod look sexy and pants that make your dad butt look sexy and new face cream that make your dad face shine. Like it's really kind of funny how much overweight father ads I get. And so like that's clearly data mined from something. Targeting me too close to home. Kevin says it's weird because that from specific case study, we're like, oh yeah, normally it'd be a good thing that the father found out, but it's definitely also a thing where sometimes the worst case scenario. It depends on the father, right? It depends on the family dynamics whether that's going to be okay or not. All right, Dee Dee says having a curated experience can be somewhat unnerving, but it's also convenient in many cases. Right. I mean, the thing that's tricky here is that it all turns on it being the story of what was data mined was pregnancy, and who it was revealed to was dad. And like it's not that like that capability isn't helpful or useful in some cases. It's that in this specific case of the prediction and the application, it was really problematic. I mean, it could have been really dangerous for the daughter, right? Or the unborn child. Josh says, I typically think about the availability of information on me as fair game as long as it can be figured out by information that I have allowed to escape, but it's interesting to think that a broader range of info than one might think. Yeah, that's true as long as it's sort of obvious what's being collected about you. But when things are being collected about you that are more powerful or in depth than you realize, suddenly you're caught off guard. How long until Noah says how long until predictions based on past behavior goes full Minority Report? Yeah, that's a good question. Minority Report has this sort of famous scene where Tom Cruise is walking into a Gap, and there are these sort of hyper personalized advertisements that are keyed off of a retina scan for his character. Andrew says at first it seems like a violation of anonymity, although Amazon would do the same if it also registered someone constantly searching for newborn supplies. Yep, in fact, Amazon's situation is very similar. I run into this all the time in my family because we have one Amazon account, one Amazon Prime account, and all of our family does the same shopping on that same account. So if I ever want to buy a present for someone on Amazon, it gets a little complicated because all of a sudden like the recently browsed history stuff pops up and all kinds of suggestions pop up when my wife is browsing right after I've been shopping for something for her. So like I can't use Amazon to purchase gifts that I want to keep secret from my family as a result. And so Etsy is kind of my friend in that case. Ben says potentially that sort of advertising would be a little bit more secure in the mail, you'd think, but that was the problem, right? Oh, an envelope, yeah, rather than a flyer. More expensive though. William says advertising is not something I've ever thought was a positive, but it could have other interesting interactions between consumers and businesses. Well, you might not think of advertising as being a positive in terms of like getting saturated with it, but it's why everything on the internet is free. So like in that sense, it's a sure positive because everything we do with, Wikipedia and email and all kinds of stuff is free because of advertising. So you might not like the advertising, but it's certainly paying the bills for a lot of stuff that you do appreciate. Are you looking at gym membership cost or at home workouts? No, I think it's just, this is probably about the fat dad. I think it's just because of my gender and my age, and possibly also something to do with beard stuff. Like, I also get so much beard stuff, beard creams and beard straightening things and beard lifestyle and Viking beard workouts, and it's a little funny. Everything on Instagram is so sort of precious in a way. Um, Kevin says creepy. Good idea to pay. We can't do anything about it. Large corporations because negatives outweighs positives. Okay. Claire, it seems invasive if she wasn't aware that it was being tracked, but seems interesting and that info is technically public. Most people just don't recognize it. Um, yeah, but like it doesn't have to be public. Like just because it is public doesn't mean we have to settle for that, right? And the reason why it's public is because what could be done with it previously was less than what can be done with it now. So if previous data was public and now new stuff can be done with it, that doesn't mean we have to like settle for it being public forever. Amazon has ruined many Christmas surprises in our household, Tommy says. When you use an online product for free, you and your data are really the product. Yeah, a common aphorism. So here's what Target has done from now on. They made a big mistake here. They sort of recognized that there was power in the advertisement mechanism itself, but that the particular thing that happened was a problem. And so now what Target and companies like it do is when they offer a marketing flyer, 75% of it will be standard and will look like everyone else. And then certain areas of the marketing flyer will be tailored to the specific individual. And so just by looking at the flyer, you don't know which pieces have been tailored to you specifically. And so you can see the bologna and the bread and the lawnmower and the back to school special. And then at the end is like newborn supplies. And it looks like the flyer is just sort of a generic flyer because who'd know? But if it detects that you're pregnant, you'll get newborn supplies. But if it detects that you're fat dad bod, you're going to get the, Dockers plus plus ad at the bottom right, something like that. So that's how they do it now. They mix in partially personalized stuff in the midst of everything else. All right, let's talk about things I think are bad big data. And this would be when we start to get in the realm of what China is working on with their citizen control. So, when sensitive data is discovered without your consent, the potential for coercion multiplies. Notwithstanding the fact that it may be public data, the fact that it's collected makes it a different kind of data. It's not just public, but it's public collected data. And the fact that it's collected by one administrative organization matters as well. So it would be different if one organization collects one part of data and another organization collects a different kind of data, but they can never get brought together. But let's say that everyone brings their data together. There's a lot more power now in the data that's been collected than was before. So Chinese citizen control is an example of this. What exactly is happening here is not entirely clear coming out of China, but I'll read you one of the more like dramatic accounts that was reported by the Washington Post. So this is a project to create a kind of social credit score in the way that we have a credit score for financial data. So in the US, one of the things that happens is that in order to get a loan, a car loan, a school, well, maybe not a school loan, but a car loan, a house loan, a boat loan, something like that. In some cases, in order to get a credit card, you have to or in order to get a lease sometimes out on the open market, you need a credit score. And your credit score is a number that is collected by private companies in the US, and it captures all the different ways in which you pay bills. So if you pay bills on time, your credit score goes up. If you have a lot of debt, but you're managing it well, your score goes up. If you have a history of managing credit well, your score goes up. And that gives companies a lot of confidence that if they're going to loan you something in the future, that you have a good track record of paying it off in the past, and so your credit score goes up, triggered by your interactions with the financial system. So what China is proposing and has been working on in various kinds of prototypes is a social credit score, a score that's similar to our financial credit score, but is geared towards more harmonious society, to use a euphemism that's translated from Chinese. And so let me quote what this article said in the Washington Post. This project, launched in Jiangsu's province, Suining County in 2010, pardon for the pronunciation, gave students points for good behavior, up to a maximum of 1,000. But a minor violation of traffic rules would cost someone 20 points, and running a red light, driving while drunk, or paying a bribe would cost 50. Some of the penalties showed the party's desire to regulate its citizens' private lives, participating in anything deemed to be a cult, or failing to care for elderly relatives incurred a 50-point penalty. Other penalties reflected the party's obsession with maintaining public order and crushing any challenge to its authority. Causing a disturbance that blocks party or government offices meant 50 points off. Using the internet to falsely accuse others resulted in a 100-point deduction. Winning a national honor, such as being classified as a model citizen or worker, added 100 points to someone's score. On this basis, citizens were classified into 4 levels. They were given an A grade, and they qualified for government support when starting a business, or preferential treatment when applying to join the party, government, or army, or applying for a promotion. People with D grades were excluded from official support or employment. That's the end of the quote. And then I'm going to add on to that your ability to travel gets limited if your social credit score gets too low. Now, this is somewhat terrifying, both because it is being, to me as an American, because it's being collected by the government, number one, and because the government in China is such a monolithic organization. By gamifying behavior, they're able to solidify their control and sort of reduce your freedom along the way. A bit scary, especially when they start preventing you from starting a business and preventing you from getting loans and preventing you from traveling. But I want to clarify that from people who have been in China, it might not be working out in quite such a totalitarian way as what gets reported in our media. Our media is super triggered by government control and things like this. It's just sort of an American thing that we really can't imagine. We really freak out if the government controls anything, as if the government was someone other than us. Nevertheless, what seems to be happening is kind of reasonable stuff. So I know that one example of real things that are getting penalized is if you owe child support payments in China and you don't pay them, then your social credit score goes down. I'm like, well, I mean, at the end of the day, you're not paying your child support. Maybe your social credit score should go down. So when I hear of actual stories of it being implemented, it seems like not so different from my values actually. It's just that the potential for abuse is really, really high. And in the US, the potential for government abuse makes us want to throw down and, take over the Capitol, for example. Just reading a couple comments. Kevin says he had a friend who went to live in China. Haven't heard from him in a few years, but he remembered that this had a huge impact on him. Censorship of anti-government messages is a huge part of it. Yeah, so censorship is a slightly different issue. Censorship is definitely rampant in China. All the social media is all censored by humans and computers. You can't say certain words. If you do, they tend to get removed automatically from the social media platforms. And so people have all kinds of ways of getting around that, like using emojis to mean concepts instead of words. So that is a kind of totalitarian control for sure, but it is a different control than what the social credit score is doing. They could be merged. For example, if you get identified as being someone who uses one of these banned words, you could have your social credit score lowered. But as far as I know, that's not actually happening. So there are ways that the systems can be merged, but conceptually they're separate systems. Sensitive data is discovered without your consent. Chinese citizen control revealing alcohol purchases. So there's kind of a famous example of the Vons Club card. The Vons card is a way of associating your purchases with you because you have a card that identifies you. You swipe it in order to get discounts on the things that you're purchasing, or sometimes rewards on the things that you're purchasing. And then that associates the things that you purchase with your account. So there was a somewhat famous example of someone slipping and falling in a Vons store, suing Vons. Vons, in order to defend itself, looks up the transactions from this individual and sees that there's a lot of alcohol being purchased. Vons begins to prepare a defense saying that this person slipped and fell because they were drunk and an alcoholic. And they were going to use the evidence from the data that they captured as part of their Vons Club card program in order to make this defense. A little scary. The case actually got settled out of court, so we don't actually know exactly what the details of how it all played out were. That's an example of sort of disconcerting big data. And again, this is like the Target example where, yeah, the capability seems like it could be used for great things. But when it's used for something not so great, suddenly we're worried about the capability being abused. And it's, I guess, kind of the same with the Chinese citizen score. In some ways, it does seem great. It would be great if, like, people don't pay child support, people who, don't pay back their loans, if they do get penalized in some way. But the abuse of it, and then the actual example of the abuse happening, is where we start getting worried. Using driver's license photos for face recognition. This is an example of data that was collected for one use, and everyone understanding what that use was, putting your picture on a driver's license. Now there's a database, because of big data and because of software, we have a database of faces associated with driver's license. And because that's available, it now gets leveraged in other contexts, primarily by law enforcement, in ways that weren't expected and that weren't subject to kind of democratic control. So the one that was used, an example of the way it was used is the FBI and ICE using driver's license photos to do facial recognition searches for, I don't know what, immigration, something. I don't know. The problem here, I think, is the fact that data was collected for one purpose and used for another purpose, and that other purpose has like serious implications for people's ability to move and live freely. I don't know the details of it though, so like we would probably have to get into some of the details to understand whether or not the particular case seems justified. But again, it's a potential, and it has a potential for abuse. And as we see things getting closer and closer to abuse, we start getting worried. All right. Now there's some of this starts getting physical, and this is where it also starts to get worrisome. It's not just online processes, it's also physical processes. For example, your license plate being read and automatically analyzed produces a trail of where your car has been. Your ATM transactions produce a trail of where your card has been, and both of these by association where you have been. Your phone checking in with cell phone towers creates a trail of where you have been. Your Fitbit records locations and activity levels. This has been a cause for concern overseas, where military members have Fitbits, show their movement through areas that are hostile, maybe not like completely locked down, but hostile. And if that information gets out or is made public on the internet, people can look at where military members are moving through environments and interfere with, kidnap them or shoot them or whatever bad things they want to do to them. Here's an example of what's happening with Android phones in particular. So Android phones are a little bit more transparent / actually collect this data. And so you can dig into your data in your Google account, and you can see, as a result of having an Android phone, where Google has tracked you. So this is someone in my family and their location tracking over time. You see the red dots are significant locations where Google has analyzed that the phone has, and by association, the family member has been. And then you can see in the timeline in the upper right how many different locations have been identified. And this, and then it'll, you can filter based on the particular day. This gets a little bit more complex because you can drill down and you can see particular patterns of movement. So this is movement over the course of a day that has been analyzed and reconstructed from partial check-ins and partial scans. So it's not like there's a GPS constantly running. It's when you check in Wi-Fi, when you check in cell phone, when you do something that has GPS, Google is able to reconstruct a trace for you. And so this, over the course of a day, you can see movement from the upper right in a location labeled home down to the bottom left to a location called Orange Coast College, and then stop and then top at Target and Trader Joe's, places where a long duration coincides with a particular store, all reconstructed from partial cell phone. This is like regular. This isn't a research. This is what's really going on in your phone. Don't know what it's used for in particular, but it's there. You can look at it. You can turn it on. You can turn it off. You have the ability to do it, to adjust it, but you may not realize it's happening. Other kinds of data, you've got your Fitbit. Over on the left is energy levels and steps. This gives a lot of indication about what kind of lifestyle you're leading. Now, it's great if you are using this for your own personal consumption. That's really helpful. I love tracking all my energy and exercise and stuff on my watch. But the idea that someone else would be tracking all my position and energy creeps me out a little bit. Over on the right is a menstruation calendar. I think this is cycles. So tracking someone's period, tracking female periods. It's on your device. It's possible to leak it. Could be of concern. Again, in the context, it's all fine. The potential for what it could do is scary. And then when we start to see those fences being broached, we start to worry. And it may be too late because the cat's out of the bag at that point. Nest thermometer, smart speakers, smart microphones that have smart speakers in them as well. Amazon speakers and most smart speakers are continually recording sound in the environment in which they exist. That sound is sometimes just kept local, waiting for the trigger word, hey Google, hey Alexa, hey Siri, okay Google, all the different trigger words. A lot of times these devices are on a local loop, just listening for that trigger word. And then as soon as it recognizes the trigger word, it records a longer period of time, sends it off to the internet for more sophisticated analysis and an answer, and then it comes back and delivers the answer. Nevertheless, we now have a speaker, a microphone more importantly, running in our house all the time, picking up data sometimes that isn't expected or that you wouldn't want to have picked up. All a story about potential and then abuse. But then once there is the potential, not much we can do to put the cat back in the bag. I showed you this one earlier, but I'll let you read it again for a sec. All right. I actually kind of want to jump ahead here. So there's a couple different ways of thinking about this, the panopticon and the capture model. We talk about this kind of quite a bit in senior seminar, and I think I'll save it for that. What I want to do instead is I want to jump ahead to that last question about how we ought to live then and think a little bit about what should we do in the face of big data. Even though this course is going to be about like managing it, we're just trying to set the context right now. And so some ideas about what we might want to do in this case. To the point of talking about capability and potential and the abuse, here is a little comic that sort of describes that. Let me see if I can get it up on the screen. No, there we go. So there's a comic called The Joy of Tech. The caption up there says the Internet of Ransomware Things. And we see a couple examples. The refrigerator saying, hungry? Pay up and I'll unlock my door. The smoke detector on the upper right says, 30 bucks in Bitcoin, or next time I smell smoke, I might just let you sleep. The broom on the bottom right, smart broom, says, send me $25 or I'll tell everyone on your social network that you were stupid enough to buy an internet-connected broom. Trash can says, if you don't send us cash, your reputation will be in the trash. So a lot of exploring this idea of what kinds of like opportunities for abuse have been opened up by the virtue of everything becoming internet connected and the data being collected as well. All right, so let's think a little bit about how we might want to live as a result. The first thing I kind of want to point out is, in my humble opinion, this is not going to be solved by more technology. I think that in many ways, technology is a tool like a knife. It is a tool like, I don't know, irrigation, right? It can be used in good ways and can be used in bad ways. And we want the good benefits, and we want to avoid the bad consequences of a lot of this data, of a lot of this technology. And the funny thing is like it's not really about more technology in a lot of cases. It's important that we are active about structuring the world that we live in socially through legislative, well, through kind of four different things: through economic pressure, through legislative pressure, through social pressure, and through code, through the technology itself. Four different ways in which we can help to sculpt the impact of these technologies. Legislation being a really important one, very hard to do in the US. For some reason, Europe has been much more successful at managing the risks that come with data collection, particularly as it entails privacy, than the US has. And I think that's largely because culturally, Europe tends to think of the government more as people being part of the government. We are the government. And the US tends to think of the government as big brother, the oppressive enemy that only wants to destroy me and take away my fun things. And so our ability to legislate requires us to use the mechanisms of government in order to protect ourselves. So using ourselves to protect ourselves. But like, what a mess, right? Hard to do. So anyway, actively pursuing and supporting legislative actions to put reasonable limits in place is an important part of deploying and creating this new technology. Otherwise, we're just going to get abused. And a big part of this is like we don't want to feel like prey, right? Like you don't want to walk through life feeling like you're a rabbit with a bunch of wolves in the bushes everywhere. You don't want to have to, every time you go out in the public square, feel like you're about to be abused or data collected, or you can't move your body or go to a store without it having some sort of implication that's going to be leveraged and take advantage of you. And now increasingly in your home with all the smart devices as well. So those are the kinds of things we would like to avoid. And that's going to be more of a legislative work. All right, so what are some options for what we could do in all this? We could submit. We just say, I give up my hands. I don't care. It's just going to happen. I don't care if they collect data about me. What can you do? What can you do? They're collecting the data. Okay, that's great. But in the long run, you lose your freedom little bit by little bit. So that's probably not a great solution. You can try and disappear. So some people are like, my solution to this is I need privacy. I'm going to go live off grid. Well, that's kind of not possible anymore. Like between smartphones and the way global finance works and just the location of video cameras, like going off grid is a reality TV show. It's not a viable option. You can get more off grid, I guess, but like you're just not going to be able to disappear for long periods of time and live, a good life. So that's not really an option. You can rebel. Active law breaking, you're unlikely to find a lot of sympathy in that because in as much as the global financial system is tracking you, the global financial system is also what's getting groceries to your table. And so trying to destroy the financial system may seem like civil disobedience or some sort of like, rebel noble cause, but like you're not going to get any sympathy from people who want those systems. You could lie. And this is something that I'm really kind of interested in from an ethical standpoint. And just take a moment to talk about this from a biblical perspective, because it's pretty clear that the God described in the Bible hates lying. It's explicitly stated in Proverbs 12:22. It's rooted in corruption. It aligns you with evil. It associates you with the fear of losing personal esteem. Even lying to avoid physical harm is frowned upon. For example, when Peter disowns Jesus in an effort to save his skin, like even to save your own, even in self-defense, it's not particularly promoted. And then, of course, Jesus is the way, the truth, not the lie, the way, the truth, and the life. However, there are also examples in the Bible that are a little bit confusing. So, and this is a quote from John Piper, it's possible to be a person who fears the Lord, walks by faith, and yet feels constrained in extreme life-threatening situations to oppose evil by lying intentionally. Some examples of this are people that have lied to protect the powerless. So a good example of this is Rahab, who lied to protect Israelite spies who were, fulfilling their role in God's plan, and also Egyptian midwives who lied to Herod when they were birthing babies and he was looking for Jesus, they both lied. And it was not, it was seen as a good thing in the context of the biblical description of it. And then, of course, protecting Jewish people during the Holocaust, it seems like something about that might be okay. And so this is a really tricky kind of thing to think about, in particular when you're talking about it from a technological standpoint. So it's one thing to lie to someone's face, person to person. That seems pretty categorically wrong, even like white lies that we like to think aren't wrong. But I'm not exactly sure that you can draw the same distinction in lying to a database. And I'm not sure if lying to the database is exactly the same as lying to a person. And this is kind of an interesting question for me. And that's because, well, kind of a long story. If you're interested, we can talk a little bit about it. But I guess the basic gist of it is that you don't have any ability to have human kinds of conversations when you're talking to a database. If a database asks you what your religion is, you can't say, well, I'm Muslim, but I'm not a practicing Muslim. Like you're either Muslim or you're something else or you're nothing, but you can't say like I'm Muslim but not the terrorist kind, like you might say in person. Or you can't say, well, I'm a Christian but I'm conflicted. Like you can't say that to a database. You get the categories that you get, and as soon as you categorize yourself as something, now all the machine learning and all the big data systems start to do things in response to that data. And so the secondary use of these answers and this unclear application of these answers in a database make it not quite clear to me what the moral implication of lying to a database is. Now, clearly, I'm not advocating lying to the IRS in your tax returns, but I'm not quite sure how I feel about lying to Vons when they ask you what your gender is. Like, why do you care what my gender is, Vons? Like, why does that matter? And am I going to support you in that? I don't know. So difficult to justify, but a little bit more complicated in my analysis than just saying lying's bad. Last thing you can do is resist, and this is probably the thing that's most effective right now. When you can opt out of data collection, especially if it doesn't have any implication on you. Also, you can mess with your data when you can't opt out. So an example of this would be like if you fly and they ask you what kind of meal you want, you could ask for a kosher meal. And that throws off the databases, especially if the next time you fly, you ask for a halal meal, which is the Muslim equivalent of being kosher. And then afterwards, you could ask for a vegetarian meal. And those kinds of things provide signals that are used in different kinds of machine learning applications. But as soon as you start making your data dirty, it confuses the algorithms a little bit. I should do something like that with my Instagram feed. Maybe I'll be like, maybe I'll start maybe I need to watch more Chloe Ting or something to confuse them. Anyway, don't make it easy. There's no reason why you have to like make it easy for people to take advantage of you. Now, maybe you want it. It's hard to say. That's what I advocate for. Here are some ways that you can do resistance without being dramatic. You can use a plugin like HTTPS Anywhere. That's straightforward and just prevents your traffic from being snooped by hackers en route. Not exactly what we've been talking about, but it's something. Privacy Badger, or there's another one called Ghostery, manages cookies on your web browser and helps to protect your ability to be tracked from website to website. Track Me Not is a little bit more sophisticated version of that. Your browsers have the ability.
Update my ICM subscription with Susan using my professional development facts.
Your browser has the ability to.
Reminders. Fill out CARES report.
Your browser has the ability to turn on Do Not Track, which is an optional thing that advertisers can look at to not track you. And then if you use a VPN, that prevents your ISP from recognizing you too much, or even Facebook in some cases, because Facebook is paying attention now to where your traffic comes from for advertising. I recommend using Signal for mobile communications. Signal is a highly encrypted way to do instant messaging. It's a lot more secure than Facebook Messenger. Facebook Messenger and Instagram DMs are the same company now. Facebook is awful about your privacy and about abusing knowledge it knows about you. Signal is a really great alternative. We use that in my family, but it's a little bit tough because you have to get both parties to use it. But if you can, it's a really highly secure platform. I think it's great. Using a VPN helps prevent your cell phone company from being able to recognize a lot of data about you. And you can just turn off application access so that your application doesn't get to see your location, or doesn't get to listen to your microphone, or doesn't get your contacts, or doesn't get your camera, unless you know that that application really critically needs it, right? It would be dumb to have a camera app that doesn't access your camera, right? But why does your your I don't know, my GM Financial app need to know your location? It doesn't really. You just need to be able to pay your car lease on it. You can do some other things with your physical body to do some resistance. You can send your phone on a holiday, so you can turn it off, like power it all the way down, and create this gap in your data. That messes with the ability of data mining to learn things about you. Of course, you might go through withdrawal and end up shaking and sweating as a result, but maybe that's good for you as well. You could trade phones with someone for a little while. You could put your phone in someone else's car and have them drive it around, and that creates what we call plausible deniability. You have a reasonable example of you not being where your phone is, so that if at some point in the future you're being accused of something based on where your phone is, you have a very easy defense, which is sometimes I let other people take my phone and I don't know where it goes. And you can just, you can demonstrate that by creating an alibi every now and then. Physically block your cameras. Some of you have things on your laptop that like physically put a block of paper or plastic or something in front of your computer camera, your laptop camera. Again, this isn't really big data mining, but this is more like hacker prevention. You can mess with loyalty cards. For example, you can use someone else's phone number when you're trying to get your Starbucks reward. You can trade your cards with other people if you have particular loyalty cards. You can register a Starbucks card on your account, but then trade it with someone else, and that messes up Starbucks's tracking along the way. And if you don't know about it, when you're in incognito mode, or private mode, whatever browser you use, your history of your transactions within the browser and within Google's ecosystem, in the case of Chrome, is not tracked and put into your data stream. Now, if you use your incognito window and then log into some website, that website is going to know who you are, and you haven't really kept yourself anonymous, but you have kept yourself anonymous from the website company. You can do it in ways that are fun. So you could record and play fake conversations when you aren't around and see if the advertising changes. So for example, you could have a fake conversation with your smart speakers to see if that changes the kinds of things that are advertised to you. You can use Facebook to go on a fake vacation by like just creating a narrative and putting pictures that you grabbed from Google up. That's sort of funny. You can change your demographics on social media. You can change your gender, you can change your age, you can change all kinds of things on social media and see what the effect is on what happens as a result. It's an interesting experiment. Now, of course, it has implications because your social network's going to see the changes. That can be fun. One thing I like to do on the 4th of July is I like to delete all my web browser cookies in a moment of revolutionary defiance. And that means I have to log into all my websites again, but it does reduce the amount of tracking that can happen of me. And you can also misspell your name intentionally on forms in order to track how your information is traded. So you may not realize this, but any email address that you use in the Gmail infrastructure, you have multiple emails available to you. So for example, my email at Westmont is dpatterson@westmont.edu. I can also use dpatterson plus and then any text I want after that at westmont.edu. And then that email will get routed to the same place, but the to address will be retained. So if you go into Sprouts and you sign up for their loyalty program and they ask you for your email address, I could give them dpatterson plus Sprouts at westmont.edu. And then if sometime in the future I see that I'm getting spam directed to dpatterson plus Sprouts at westmont.edu, I know that the origin of that spam was from the Sprouts loyalty card sign up. And so that's interesting. It's interesting just from an educational perspective to learn that. It also gives you the ability to filter emails specifically on that to address. And so they don't look like this, they don't look the same as all the other emails that you might get. So it's kind of like you have an infinite number of emails that are all getting routed to the same email address when you use Gmail. Okay, so that kind of wraps it up for what I want to talk about. In these lecture slides, which I will post online, are a bunch of information about the articles and the backstory of a lot of the things that I described today, including a couple places where you can talk about privacy stuff. And I guess the bottom line is what this is all doing for us is in conjunction with our web search lecture, this is giving us the ability to have some context for how this big data is being used as we start to dig into the technical details of how we build this stuff. This is really at the 10,000 foot level, and from here on out, we're going to start diving into the weeds quite a bit, programming it, but I also want us to be cognizant of what it is we're programming so we're not just stumbling blindly into the future, and we can direct it a little bit. So that's what I've got for us today. We're just a touch over time, so I won't delay anyone, but I will stick around in the virtual world if you have any questions or any comments about anything. Otherwise, thank you for your attention. I'll see you in person in class on Thursday, and we'll be talking about chapter 19. So if you want to read 19.1 to 19.4, you'll be getting ahead for the quiz. And I'm going to shut down the broadcast in the meantime, but I will stay in game.
Thank you. All right, thank you. See you then.
Thank you.
Dr. Patterson,
Yeah, stand by one sec.
I might be a few minutes late to my office hours appointment at 5 tonight.
Okay. Okay, got it, Josh. Thanks. All right, this is CS-128. It's December 7th. We are wrapping up. So long, YouTube.